So what we're going to look at now today is we're going to look at the matched pairs test example. So suppose that we wanted to determine if a treatment was effective in improving attention in children with ADHD. The children are given a task and the length of time that it takes to lose focus is recorded. Higher times indicate better attention. On another day, the same task is given after the children are given a focusing and attention exercise. The time that it takes to lose attention is then recorded. The researchers would like to know if the treatment is effective in improving attention. The test that we're conducting in this experiment is a matched pairs test because it is the same group of children and we're testing them before and after they are given the treatment. Thus, the two samples, the before and after, are from the same group of children and are dependent. We're going to ignore the effects of repetition here and assume that the children do not improve in focus or attention with repeated trials on the test. All we want to see is whether or not before they have a lower focus and attention time than afterwards. Do they spend fewer seconds on attention before the treatment than they do after the treatment? Okay, so we're going to start out with our null hypothesis, and symbolically our null hypothesis is going to be mu d is equal to 0. And what this means in words, our h naught is the mean difference in attention time before and after the treatment is 0. Another way to put this is that there is no difference in the mean attention time before and after the treatment. So those are two different ways that you can actually write this. Before and after the treatment is 0. Okay? And I'll give you an example of the other one in just a second. For the alternative hypothesis, we're going to say that mu d, okay, is going to be greater than 0. And the reason why is because we're going to take the after treatment time and we're going to subtract from the before treatment time. Okay, so we imagine that the after treatment is going to be longer and the before treatment is going to be shorter, so longer minus shorter should be positive. So that's mu d is going to be greater than 0. So we'll say something like this. The mean attention time before the mean difference in attention time before and after treatment is negative. Is positive. My bad. It's greater than 0. Or we can say the mean attention time improves before improves after treatment. Okay? Basically what we're saying is that the treatment allows students to pay attention more. Okay? Notice symbolically we've got mu d, that's our mean difference, is going to be greater than 0. And our null hypothesis is strictly that it's going to be equal to 0. Okay? And that's just basically our standard hypothesis testing writing. Notice here too that I'm basically saying what it is that I'm in fact measuring. I'm measuring difference in attention, and we could even say attention time. Okay? And then I say before and after the treatment. Mean difference in, again, attention time. Okay? Mean difference in attention time. And that actually lets everybody know, you know what? We're measuring attention time. Now we're going to examine our data. Okay? When we examine our data, we're going to basically look for the requirements of this test. Each sample is sufficiently large, our before and our after. They're going to be the same size because they're matched or paired. So basically our sample size has to be big enough, right? Greater than 30, or there are no large divergences in the differences. So we don't see any huge outlier differences, right? They basically all are pretty consistent. The data is taken from dependent samples, so we need to make sure that that's the case, or else we can't run a matched pairs, and a simple random sample for assignment of the participants. That's one of those general things that we just have to make sure that we don't have any real bias, okay, or a lack of representativeness inside of our samples. So I go into StatCrunch, and right now I'm going to first check to see, do I have enough sample data? Okay, if that's the case, then I can kind of move on as long as I know where the data is taken from. Well, look at that. I've got 130 n, or 131 n. Okay, degrees of freedom 130. So I have 131 n, and that's great because what that allows me to do is that allows me to say, you know what? I can assume that we can use the t-distribution. All right, this allows me to actually do the test. The requirements are met. I also look and make sure that I have before and after for every single person inside of the sample, and I do. If I didn't, I'd have to go out and remove them. Not something you really need to do, no, but like that's how we deal with it. If we don't have a before and after for each one of the members of or the participants, we remove that participant. So now what I've seen is that my requirements are met. So my requirements are met. Once I've known that the requirements are met, I can go in and run the test. So I'm not going to run the test inside of this video because what I'm really interested in is your interpretation of what's going on once we get the results. Okay? There will be opportunities for you to actually run the test. It's not difficult, and I have videos assigned for those as well. But for this purpose, I'm going to take a look at the actual results. So here are the results of my test. One, you notice that I've got my null hypothesis, mu d equals 0, and then I have my alternative hypothesis, mu d is greater than 0, okay? And that is accounted for mu1 minus mu2. Mu1 was my after, and mu2 is my before, okay? That's how I set it up, okay? And it says mean difference of between after treatment and before treatment. So notice they've got the after first, right? First, and their before second. Tells you the order in which everything was subtracted. Then I've got some sample statistics. I can kind of look. The after treatment has a mean of 54.877, and the before had one of 49.67. So that at least suggests that maybe there's a difference. And then I go down here, and this thing here, this is what's called D. Okay? D, that's the sample difference, or the average sample difference. Okay? You got your degrees of freedom, 130. Right? If you remember, that's n minus 1. And then we have my t-stat of 6.1395. That's a really big t-stat. And then I have a p-value less than 0.0001. And so that tells me, what is that result? What's that result? P there is less than 0.001. Okay? So alpha, we know, because you're in occupational therapy, will be 0.05. So P is less than alpha, right? P 0.0001, or less than that actually, is less than 0.05. So this tells me I'm going to reject the null hypothesis. What that means is that our sample is statistically very rare. Okay, if in fact it was the case that the treatment had no effect. So rather than us thinking that it's rare, we're going to say the treatment had an effect. Okay, and that's why we reject the null hypothesis. We don't believe in things that are super duper duper rare. Instead, we believe that our treatment worked. So let's go back and let's take a look at the null hypothesis. Okay, here it is. Our null hypothesis was mu d equals 0. That is that there's no difference, okay, in the attention time before and after treatment. We're going to reject that now. That means that we'll support this one, that the attention time was actually greater than 0. Okay, the attention time was greater than 0, and so consequently, we reject the null hypothesis. Since we rejected the null hypothesis, this suggests the treatment was effective in improving attention. Okay? So as you're doing this, be very systematic in your thinking, right? 1, first ask yourself, what's the question that's being asked? 2, and I'll even write this down here for you. 1, what is the question being asked? Okay? 2, what is the test, or actually let's ask ourselves, what is the experiment that is being run? How is it being done? That's going to actually really help you out and inform you in understanding what your results mean. What is the experiment being run? And that's basically a general sketch. In this case, we measured focus and attention before treatment, then we gave a task, and then we measured it after treatment. Okay? So we got this before and after treatment. That tells me I'm going to be running a match pairs. Okay? Which is the appropriate test? That's my 3. My 4, okay? What is the null and alternative hypothesis? 5. Interpret our results. Basically P less than alpha, okay? Right, reject the null. If it's not, you fail to reject. And finally, interpret our results, or interpret our conclusion. Tell what our results mean in terms of our conclusion. The more systematic that you can be inside of your thinking, the easier this gets. Okay, it's broken down. And so like instead of the literature review assignments for the tests, what I'm trying to do is trying to help you just think through the process so that you understand what the results mean.